Well, good afternoon, everyone. Welcome back to the CAFNR Research Council webinar series. As you may recall, we started off the CRC webinar series as an in-person coffee and conversation before the pandemic. Dr. George Smith, our own Nobel laureate, was the inaugural speaker. Well, we changed our format to a webinar following campus shutdown back in the spring of 2020. We really would like to bring the coffee and conversation format back, but we'll wait until spring. Today is our second webinar of the fall semester, and we have one of our newest faculty members, Dr. Jordon Wade, from the School of Natural Resources, as our speaker. Dr. Tony Lupo, professor from the same division and a member of the CRC, will make the formal introduction. But before then, I would like to say a few words about the CAFNR Research Council. Some of you may have heard this before, but we formalized the CRC about 2.5 years ago as an advisory council that would provide advice to my office, that is the CAFNR Office of Research. We do have faculty from every division represented on the council. We also have staff, graduate students, and postdocs represented. This webinar is an example of some of the other activities that the council is engaged in addition to providing advice to my office. They help me in making important decisions. And when they do so, they are representing you, our faculty and staff and students. In other words, CRC plays an important role in shared governance in our college. Before I hand over to Dr. Lupo, let me remind everyone that you need to post your questions in the Q&A box, not in the chat room. You will see the chat room also there, but please don't forget to put in your questions in the Q&A box. Dr. Lupo will be moderating the Q&A session in the end. So without further ado, Tony, the floor is yours. You are muted, Tony.
Good afternoon. I'm very pleased to introduce a colleague, Dr. Jordon Wade, and he's going to talk about soil health in Missouri and beyond. But let me tell you a little bit about him as a young faculty member in the School of Natural Resources. And he's a graduate of Ohio State University and their environmental science and natural resources program. And he earned his BS and MS from the University of California at Davis, or UC Davis. His research involves improving soil health, which can have a lot of desirable effects ranging from increased cropping, nutrients, and better usage of the land, better animal productivity, changes to biodiversity and resilience to abiotic stress, and more. And he brings this kind of expertise with him. And he's going to talk to us today again about soil health in Missouri and beyond. And so Professor Wade, take it away.
Wonderful. Thank you, Dr. Joes and Dr. Lupo. And thank you to all of you for coming today. I wanted to start off by, maybe a bit more in the about me very quickly. So I did my BS and my MS at the University of California, Davis. My bachelor's was in soil and water science, my master's in soil and biogeochemistry. So, that's really where my roots lie, as one might guess, with a soil health position. Then I went to Ohio State and I did my PhD in the School of Environment and Natural Resources. It looks very similar to the School of Natural Resources here. And there I got the chance to work and have a lot of experience with a lot of interdisciplinary scientists, and especially working with some decision scientists and environmental social scientists there, which I think you'll see come through a little bit here in my presentation. Then I did my postdoc at the University of Illinois, Urbana-Champaign in the Department of Crop Sciences there to kind of round out the agronomic toolkit there. And I'm really excited now to be here at the University of Missouri in the School of Natural Resources. Now, I figured, soil health is something that there's probably a little bit of uncertainty and a little bit of gray area on. So I figured I'll start at the beginning. Soil health is the continued capacity of a soil to function as a vital living ecosystem that sustains plants, animals, and humans. Now, this is the USDA definition. And, as academics, I think, when we read something like that, a couple things jump out about a little bit of ambiguity there, right? So for example, the continued capacity, we could ask how long and what is that capacity and what does it mean to function and things about sustainability, et cetera. We really key in on those types of things. And I think that that's natural because this definition is fairly difficult to operationalize. And so I think that we're not alone in that. I think that farmers, growers, land managers, et cetera, similarly are not quite sure what to do with a definition like that. And they are very interested in how to put this kind of framework and this approach into action. So I want to start with kind of rethinking soil health from the ground up. This is a bit of a different approach and really drew on my interdisciplinary associations and collaborations when I was at Ohio State. So I wanted to start kind of at the beginning here. So soil health is something that was a term kind of that came into vogue because farmers really kind of attached themselves to it. They thought it was a very appealing framing. And so therefore, I've done some research and I asked the question, how do farmers conceptualize soil health? How do they think through it? How do they see it in their kind of the context of their whole farm operation? And I want to know, how does this conceptualization differ from other populations, right? So farmers have all kinds of things that are on their mind, things like equipment availability, they're very attuned to the weather, they have their varying levels of experience and context, they're thinking about input costs, what's the cost of fertilizer is especially salient right now, but then they're also thinking about their unique context, where are they geologically speaking or in the landscape position, and they bring all of those things together on a farm in this dynamic, ever-changing environment. Now, that all kind of comes together in their mind, in their experience, to form what we call a mental model. So when we talk about that mental model, you could see that those different starting places might lead to very different mental models amongst different groups. And so to me, soil health means that you want something that is implementable, and therefore we want to think through mental models of soil health. And specifically, I was interested in kind of 3 different populations. So of course, farmers, as they are kind of the end users and implementers of soil health, researchers, it's good to do some introspection on ourselves, and then also working with government employees, the USDA, NRCS, they're kind of soil conservationists. NRCS is a big proponent of soil health, as is USDA. And so thinking through how they conceptualize and approach soil health is an important part of kind of operationalizing this definition. So to kind of unpack these mental models of soil health, we did this kind of preliminary interviews to develop a survey. So we sent out the survey and we sent it out to these 3 different populations. And once we got the inputs back, we did a little bit of preliminary data analysis, sat down in focus groups to say, hey, does this make sense? Are we interpreting these survey results? And then we kind of put it together to construct a mental model. Now, specifically, we asked the question, to you, an increase in one theme causes what effect on another theme? Now, we developed those themes from those preliminary interviews, and we kind of came up with 6 different themes. So these are soil physical function, soil fertility or biological functioning, agrochemical inputs, just broadly, cropping productivity, profitability, and environmental harm, and then of course, soil health. So we wanted to see how soil health nestles into these different themes that came out from these different groups. And we want to kind of develop causal linkages in how people approach this. So when we asked the question that way, we said, does it cause an increase? Does it cause a decrease? Or is there no relationship in your mind? And so with phrasing the question like that, we kind of get 3 layers of information. So we get presence, absence of a linkage. We get a direction. We get both we could get a unidirectional, right? That causality flows in one direction, or we could get a bidirectional linkage, which would mean that these things are related to one another. And then we can also get, is it increasing? Is there a positive relationship, or is there a negative relationship? Now, when we start to put all of those together in this sort of network-based model, we get start to get a picture of how different groups causally link these things in their mind. So we developed what's called a consensus model. So this is the mental model that 80% of farmers agreed upon, both in terms of the linkages and in the direction of causality. Now, you'll notice there's lots of things to kind of unpack and look at here, but I want to draw your attention to a couple things. First off, that soil health just generally is very key in farmer thought process. It's very central. And we kind of evaluated this in 2 different ways. So first off, we use something called the betweenness, which says that information is more likely to causally flow through soil health than through other concepts. So for example, X causes Y, but only through its effect of soil health, okay? Also, we looked at the information centrality of soil health within these mental models. And we saw that soil health has a greater control over that flow of information within the network, within this mental model, than any of the other nodes within this, right? So this right here is an example of the farmer mental model, but we also had that for other groups. So this gives us some sense of how farmers and all 3 of these groups really causally link soil health to these other on-farm and off-farm topics. Now, none of this really tells us how important soil health is to farmers. And so we asked farmers, when you think of your whole farm operation, how important is soil health to you out of 10? And then for the other 2 groups, we asked them, how important do you think that soil health is to farmers? Now, farmers ranked the importance of soil health about an 8.5, 8.4 out of 10. So very important. Now, these other groups severely underestimated how important soil health was to farmers. So NRCS was on average about 5, and researchers, we were in the neighborhood of about 6. So these are clearly underestimations. And the takeaway from this is that soil health is much more important to farmers than we think. And by we, I mean literally us, researchers, academics, etc. And so clearly this shows that farmers are allies in any operation to improve soil health. We don't need to convince them of the importance of soil health. They are already there. They care about soil health. So that's just a little preliminary kind of some survey results to say, this is why soil health is important, and it's not just important to us, it's important to stakeholders. But from a natural science perspective, it's good to kind of step back and think about this from a 10,000-foot view. So on farm, we have management. So there are all different types of management. Some of those things are more beneficial than others, right? And so we have these kind of suggested management strategies, things like plowing and tilling the soil less, things like diversified crop rotations, etc. There are lots of different beneficial managements. Now, farmers, any sort of land manager wants to know, how does that management link to a specific outcome, right? Now, these outcomes can vary widely from place to place, from crop to crop, etc. Could be, I want greater nutrient efficiency. Could say, I just want maximum yield. I want most efficiency. I want to improve water quality. These are all different potential outcomes. Now, the tricky part of prescribing any sort of management is that there is no kind of one size fits all. And the reason there's no one size fits all is because there's a wide range of things like climate, the underlying geology of any specific field, how long a management has been in place, or soil texture, things like this. These are all well-known mediators of the effect of management on something like productivity, right? So this is where soil health assessment comes in. It is kind of our way of smoothing out between management and outcomes. So in this way, soil health assessment is really key in translating some sort of intended management that a land manager might have into outcomes. It's kind of the bridge between these two things that takes into account context dependence. So generally, soil health assessment will rely heavily upon what we call soil health indicators. Now, soil health indicators are these tools that are meant to assist growers in translating that management into their desired outcome. These indicators have, a couple different considerations of what we can think of as a successful indicator. So from a lab perspective, we want indicators to be really high throughput. We want to be able to do lots of them because we want to be able to get information out quickly, right, to inform any sort of land manager decision. We also want these indicators to be repeatable, both within a lab and across labs. If we send a same soil sample to 2 different labs, we want to get a comparable value. Similarly, if we run the same sample twice in a lab, we want to get a pretty comparable value. That's how we get reliable measurement. And so there's a couple different ways to get at this. And this is something that I've been extensively involved in, but it's very nitty gritty, so I'll spare all of you. But things like method development, what corners are okay to cut, how can we increase this throughput, but also something like a laboratory ring test. So for those who aren't familiar, a ring test is when you take a set of common samples, say 20 different soil samples, and you send them to 10 different labs and you have them run it a couple different times. And you compare the results across those labs to see the consistency of the results that you get. So that's an important consideration for kind of taking these soil health indicators at scale and commercializing them and being able to really provide meaningful information at scale. Now, from a kind of on-farm context, we also want these soil health indicators to be sensitive to a change in management. If a farmer is going to make a change on their field, we want to make sure that that shows up in our indicators, right? We want to be able to detect that. Another important part is that when we have those indicators, we also want the output from them to be easily interpretable, right? Even if the information is good and the indicators are sensitive, if we can't transmit that information effectively and in a way that can actually inform decisions, then we're not fully succeeding in realizing the potential of these indicators. Now, this is some work from my PhD that we worked on interpreting these common soil health indicators. So we had this big multi-site study across 10 states. And so we had a lot of different types of managements here, and we kind of paired them in all of these different studies. And so we looked at these and we wanted to say, hey, can we reliably use these indicators to kind of give us a heading? Which direction are we going? So, I'll spare you all the nitty gritty here, but what we found is we found some very consistent results across all of these contexts, across all 10 states. And surprisingly, I think even to us, it showed up in 100% of our sites, which is a confidence that we don't often get in research. And so what we found is that when we took any specific site and we threw all of our observations together, the managements that we're stabilizing organic matter, soil organic matter, building soil carbon, were consistently associated with this indicator, permanganate oxidizable carbon, for those who are in the weeds on this. And then for managements that were more associated with greater nutrient release. That was another different indicator, mineralizable carbon. So what this says is that we can use these two measurements in tandem to be able to inform land managers. So this framework is really usable by them because what they can do is they can go out on their field, try out something new on just part of it. So say, I want to graze animals on here and I want to put some manure on here or something like that. They can go out, try that on one half of their field, take soil samples from the place that they're experimenting with and kind of their business as usual. And they can compare the results and say, hey, am I heading in the direction I want? If you want to stabilize this organic matter, this soil carbon, you want to be up here in this range. If you want greater fertility, then you want to be down here in this range. And so they can really use these tools to give themselves a general heading. Now, this is semi-quantitative, unfortunately, but it does give us kind of a quick and easy way to guide decision-making. Now, up next is kind of a very common claim when people talk about soil health. They say healthy soils are more productive soils. That is, you get more yield per amount of fertilizer added, more resilience, things like that. This is a really common claim, and in fact, a key claim of soil health advocates. However, there hasn't been a lot of support for that in terms of showing up in these indicators and being able to causally link these indicators to more productive soils. So this is some more work I did in collaboration with folks from across, this was the Eastern Corn Belt. And so what we did is we took a bunch of corn systems because, we love corn here in the Corn Belt. And we were looking at nitrogen fertilizer rate trials. And so layered on top of that were all sorts of conservation practices. So again, things like cover crop, variations in tillage intensity and frequency, how many crops we have in a rotation, and also manuring history. So we had 30 sites on this one that are spread across 5 states of the Eastern Corn Belt. And we really combined both on-farm work and research plots. And in terms of climate and soil types, these sites really gave us pretty good bang for your buck in terms of they were representative of about little over half of the rain-fed corn acres within the Corn Belt. So we had some good reach with this. But when we were starting to put this together and trying to definitively causally link these things, we ran into a couple kind of deficiencies in how people have been approaching soil health for the last little bit. So the first one is measuring soil health. So when we talk about soil health, we have all kinds of measured variables. We measure a lot of different things, and we're not always sure how to put those things together and make sense of those and causally link it, right? And the reason that that is so difficult is because soil health is not something that we can directly measure, right? Unlike human health, we can't go out and just ask the soil how it's feeling. And so we need to really rely heavily on these measurements. And we take those measurements and we try and combine them together to develop a single soil health score. And we rank it from 0 to 100 and say 100 is great, you have great soil health. So what that is we're kind of bringing those things together into this constructed variable. Now, scientists are humans and we are fallible. And so sometimes that kind of the way that we combine those things together is somewhat arbitrary and can be difficult to verify. And then you end up getting all these different conflicting views on this. And you say, well, we're here in Missouri and it looks very different for us than if you're in Washington or if you're in Georgia or Florida or something like that. And so there was really difficult to get people to agree on how to combine these measured variables to accurately represent soil health. So we kind of took a different track and we said, now we know that these managements have some effect on soil health. We don't know which measured variables accurately capture that, but we do know that there's a change in underlying soil health. So we kind of flipped causality here and we said, there's some underlying variable and it's showing up in our measured variables, and we're kind of agnostic about how that happens. Now, social scientists here might be familiar with this. It's something called a latent variable analysis. This is a really old statistical approach. But what it does is it takes the correlations between measured variables, and it says that there's the shared correlations between these variables is because there's some underlying trait that is causing them, right? And so in the context of soil health here, we say there's some underlying soil health trait that is causing the changes in measured variables. This lets us actually discover what these soil health traits are rather than arguing about how to best put them together. And so it's much more of a discovery process than a construction process or a formative model. So that's the first conceptual obstacle that we kind of had to get over here and confront. Now, the next one is that every field is different. Every field kind of starts in a different place. So this is a real concern when we're comparing across multiple sites like this study, right? So generally in soils, what we do is we have multiple sites, which you can see here is I'm representing with these outermost rings, and we go and we take multiple soil samples from those sites, and we say, okay, this represents the range of soil health in this field. Some of them are from treatment, some of them are from a control, etc. Now, what happens all too often is that people just completely pool them together. And so what happens is all of these get put together in this very simple X versus Y regression. And this can overestimate the effect of soil health on, for example, yield. Now that happens because some of these fields start at a different spot than others, right? They have a different kind of baseline than one another. And so we're confounding our site effects from the effect of our management. So that's one approach. Now, another approach that people have is what's called no pooling, where you basically just average all of the values from that site and you say, this is our average soil health for the site. Now, what that does is it kind of collapses some of this information, and it makes it so we can underestimate the effect of soil health. So to kind of split that difference, we did something that's called multi-level regression, which some are probably familiar with, but for those who aren't, what you do is you take all of those different measurements and you let the intercept vary. And so what we're really doing here is we're controlling for the effect of site, and we are able to move along each site's individual gradient of soil health. Now, this has several advantages. In addition to being kind of more precise science, it also helps with interpretation for any given site. And I'll kind of come back to that later. Okay, so we have these different conceptual obstacles, these hurdles that we had to get through in terms of the kind of the conventional soil health thinking in terms of how to measure these things. Now, of course, we want to convert this into a testable model. So we use that multi-level regression and we kind of throw all kinds of things in here. We have different site variables, things like precipitation or mean annual precipitation, temperature and the seasonality of it, kind of inherent site characteristics like soil texture. And we parse those apart from the true kind of management and soil health effects. This is really, again, constraining it to make sure that we are causally isolating the effect of soil health. Now, what we found is, and I'm sure you're wondering, is a healthy soil actually more productive? And the simple answer is yes. And so, soil health positively influenced yield in all of these sites. It was consistent, right? And roughly speaking, about a 20% increase in soil health translated to a 5% increase in yields. Now that you see here, this soil health variable is causing an increase in relative yield here. Now, the interesting thing is that fertilization with nitrogen also increased soil health. So this says that we can't just do away with using fertilizer entirely. We do need some fertilizer to maintain soil health, but building soil health also will help us with yields, all other things considered. For those of you who are more statistically savvy, I will also just say that the model fit on this was pretty great. I will just leave it at that. Okay. So going back to this approach towards soil health, where soil health is kind of an underlying trait, we want to make sure that this phenomenon that we are measuring, this latent variable, is repeatable. Now, there are different ways to think about reproducibility, but in this context, the type of reproducibility that we are looking for is conceptual reproducibility. So I've worked with a couple collaborators and we've been able to get this conceptual reproducibility of our initial results that we found, that these measured variables come together in a predictable way in various contexts. So we've done that in North Carolina, which is obviously very different from the Eastern Corn Belt, and also in New York. Now, I'm here in Missouri, and so this is a kind of new question that I'm going to be looking at, just making sure that this approach, this way of thinking through soil health, is also applicable here in Missouri. Now, this is talking a lot about that assessment and how we link that to outcomes. Now, remember, what we're really trying to do here is we're trying to use these soil health indicators as tools to link them to the outcome. And we want to make sure that we want to make certain that those tools are actually linked to outcomes. Things like yield, for example. Now, we can't forget the management piece, right? So that management piece is, we have all of these varying fields and we have different managements out there, and this can take a lot of different forms. And so this is kind of the place for ongoing work here, right? Figure out what managements might work and if those show up in our assessments the same way that they have in other places. And of course, we're trying to link that to some sort of outcome. Now, I mentioned before that one of the advantages of using this multi-level and random intercept approach is that for a grower, for any specific land manager, this makes it so they can be sure that even if they have a different starting off place than everyone else, that as they move along that soil health continuum, as they improve their soil health, that they can have a somewhat reliable change in their outcome of interest. Now, that outcome of interest might vary, and we're going to have to investigate all the potential outcomes that people might be interested in. So this is where the Soil Health Assessment Center comes in. Now, University of Missouri has this little known gem, or underappreciated gem, I'll say, the Soil Health Assessment Center. One of my hats that I get to wear here is I have come in as the director of the Soil Health Assessment Center. Now, the Soil Health Assessment Center has this history here of lots of support from stakeholders within Missouri. Department of Natural Resources has been a really wonderful supporter. Missouri's state level NRCS, and also the University of Missouri has kind of stood by the Soil Health Assessment Center and invested in it heavily. So in continuing with that, I hope to develop the Soil Health Assessment Center and have it be public facing in making this, translating these managements into outcomes and kind of bridging that gap and giving Missouri landholders and land managers that certainty. So specific things that I'm hoping to address in the near future is just keep doing our due diligence on the robustness of these indicators, right? So are these indicators repeatable over space and over time? Can we go to the top of a hill and can we get similar underlying traits as when we are at the bottom of the hill? Now, they might vary in where they are in terms of higher or lower, but is that underlying trait still there? Now, we also want to make sure that this can happen across different soil types. Missouri has a real wide range of soil types across it's quite breathtaking, actually. And so we want to make sure that this is, again, robust to these varying soil types. Also, Missouri has a wide variety of different systems. I've talked a lot about corn here, but clearly Missouri has many other crops. If you're down in the Delta, you have cotton. You can also talk about things like animal management. We haven't really discussed that, but soil health is a big component of that as well. So we want to think about it in these different systems and see if these indicators are robust to those changes in system. And of course, we want to test them under dynamic on-farm conditions. Missouri has a wonderful strip trials program and a really robust extension. And so, SHAC is really excited to work in that, to really do this work on Missouri farms, because that's where the rubber really meets the road, and to, build our relationships with Missouri farmers. So the second kind of big area that we want to talk about at the SHAC is connecting these assessments to specific outcomes, right? These indicators that we run are diagnostic tools. They're supposed to say, this area is going to be highly productive or it's not. And maybe it will give us some insight onto which managements and tweaks in management and changes, et cetera, might be able to improve whatever outcome it might be. Now, in terms of those outcomes, so far we've talked a lot about yield, but that is far from the only thing that people are interested in, where farms are multifunctional operations, right? So we could think about resilience in a drought year, for example. We can also think of efficiency. Where do you get the most crop per drop of nitrogen fertilizer, or what have you? We also want to think about off-farm impacts and how farms can play into that, and soil health can be an important component of that. So things like water quality, soil health has a really important role to play. And then within these kind of recommendations, we want to better constrain and refine those and increase the certainty in those recommendations by incorporating things like weather forecasts or projections and whatnot, or under climate change scenarios, those types of things. We want to make sure that these indicators are robust to that, and that our recommendations coming out of that can also give us some information about how to manage those sources of uncertainty. So the long-term goal here is to decrease that uncertainty. And specifically, we are looking to to translate that caring about soils that I talked about at the very beginning of my talk. Remember, farmers care about soil health. They care about soil health a lot on their farms, more than we realize. And we're trying to transfer and translate that care about soils into caring for soils and implementing managements that improve the health and the functioning of our soils. And of course, the long-term goal is to maintain profitability and efficiency on Missouri farms. So with that, I would just like to say thank you all for coming today. Thank you for the opportunity to present. And I guess now is the time that we do the comments and questions, et cetera, that you have sent to Tony. So thank you, everyone.
Okay, thank you. Thank you, Jordan, for a very interesting presentation. And I'm not seeing any questions on the board right now, any open questions. So maybe I'll start off with one myself. Being a weather forecaster, is how would you envision linking long-range forecasts into the soil, into your model? Generally, when we do long-range forecasts, we're forecasting for temperature and precipitation, maybe 3 weeks into the future, maybe a season or two into the future. What kind of inputs would you be looking for?
This is a fantastic question. And this is one of the reasons too that I'm really excited to be in the School of Natural Resources, because we do have this atmospheric science expertise kind of in-house. But to your question, when we talk about seasonal trends in precipitation or temperature, those types of things are a huge source of uncertainty for growers, right? And so when they make management decisions, they don't know what is coming. So soil kind of mediates any of those effects on crops, right? So for example, precipitation variability might be more of an impact in soils that are sandier than in soils that are less sandy, right? So incorporating that type of projection into a soil test and a soil recommendation is one potential integration here. SHAC is fortunate enough to have lots of farmers who send us samples, and they're looking for management kind of prescriptions back. We send out, over 1,000 every year to farmers. And so, if we can work with farmers, all those stakeholders, and kind of couple these different things, that seasonal precipitation and temperature with soil variables, and then validate, and kind of ground truth that. I think that that would be a really powerful thing that farmers everywhere would appreciate, and also would really be a nice interdisciplinary approach to confronting some of these wicked problems that we have in society today. So thank you, Tony.
And we are getting questions rolling in, and we'll take them on as they come. And the first one is, what do you see as some of the opportunities with SHAC to help farmers with their soil health interests in the next few years?
Well, I think SHAC is building this kind of, we're building, I should say, I am personally building on these kind of pre-existing relationships that exist here and the long-term support that we've had from different stakeholders. So, I think that one thing that we could do is we're starting to develop, and we're running kind of field trials to say, here in Missouri, how do we take these soil health indicators and how do we translate them to increases in productivity, increases in efficiency, increases in even just how well the tractor goes through the field, that type of stuff. And these are the types of things that I get a lot of questions from farmers on generally. And I'm really hoping that SHAC can be a valuable tool in their tool belt to help guide those sorts of decisions and management on farm.
And the next question that I have is, in your farmer surveys, was there any concern about chemical inputs into their management that may be affecting their soil health?
So nobody expressed any concerns about the chemical inputs. Many farmers would say something like, oh, I'm trying to decrease my inputs, but I'm not sure yet. They're trying to kind of optimize it. They don't want to spray more or apply more things than they have to, because that's potentially money out the door, but they also want to mitigate their downside risk. So, this is something that people kind of expressed concern about, but not necessarily specifically with regards to their soil health. Now, one of the things that came out of that survey, I couldn't delve deep into it, but that consensus model showed that 80% of farmers thought that if we increase our soil health, we can decrease our inputs, whether that be, and some people wrote in the comments section or in the margins of their survey, oh yeah, I think this decreases pesticides or it decreases fertilizer. We kind of lumped those together for simplicity in the survey, but people were, they did kind of allude to that.
And the next question follows on from that. Is there any evidence that trace metal concentrations can be an indicator of soil health?
Yeah, so this is an interesting question. And I think this largely depends on how you approach soil health. A lot of people think about soil health as meaning how the biology is functioning, how the soil microbiology is kind of in an interdynamic dance with the plants, et cetera. Now, I think that if we're talking about soil health as it relates to human health, I think that trace metals are an area of prime concern. I think I think it's very important, I'll say. And it's kind of underexplored. I think there's a lot of people who work on trace metals, but they don't always kind of frame it and package it within this soil health context. It's definitely something that I have a little bit of experience with and I'm interested in, and to me fits within this broad umbrella of soil health, especially when you think about it in terms of urban agriculture and backyard gardening and that type of thing. So I see it as linked, although many people might not see it as part of it.
Well, thank you. And I've got another question that I need to summarize here. Many of the assessments we see are quite qualitative, but admittedly can easily and inexpensively be performed by farmers. Where do those assessments fit in, or should we discourage over-reliance on those kind of tests?
Yes, so I will say that I mixing that kind of experiential qualitative data with more quantitative lab-based data is totally feasible. I think that, we have to kind of balance those two, but they are in fact quite complementary ways of thinking about soil, and especially thinking about soil health. Now, if I were to be betting, I would say that you need both. I think that these kind of smell, et cetera, can be informative, but they're not necessarily where the buck stops. And as the saying goes, I wouldn't bet the farm on them, but they're definitely one input. And, I've seen some efforts to kind of integrate those with more quantitative lab-based data. I myself haven't explored it as much, but I do think it's a valid source of information, especially because farmers are out there in their fields every day. They know it well. So I don't think we should discount that at all.
Okay, and to go back to the trace metal question, does SHAC has the capability to measure that?
Not yet, but it is a thing that I am looking forward to. It's definitely an area of interest. We don't have that capability yet, though. I would like to get there one day. But currently, that is not the main thrust of what we are doing.
Okay, we've had a good, robust question and answer session. And I'm not seeing any more, so we'll probably just move into the closing phases. And of course, colleagues can email you if they have any other questions, I think. So, and you're definitely in Outlook, so. Yeah,
please do. I'll say that, I like to work across disciplines, and that interdisciplinary experience serves me well. So if you see soil health as being part of something, part of your research program or complementary, feel free to email me. I would love to talk.
Thank you, Jordan.
All right. Well, let me also add my thanks to our speaker, Dr. Wade, for an informative talk and the lively discussion that followed. Thank you, Jordan. And thanks to all of you for attending today's webinar. Our next webinar will be on December 2nd. One of our newest faculty members, Dr. Craig Schenk from Biochemistry, our Division of Biochemistry, will be the speaker. Again, thanks everyone. See you next time.